Hey everybody, thanks for coming today. I really appreciate you coming out for GTC and coming to the Introduction to USD talk. My name's Dirk Van Gelder. I work on the NVIDIA Omniverse team, and before that worked at Pixar for a number of years. I hope you're having a good GTC. Before I get started, I wanted to remind you that we are available online to chat. This talk is pre-recorded, but during the GTC session, we're available to answer questions. So please click on the chat button on the bottom right of your browser and talk to us online while this talk is going, because we want to have some company. And I also hope that you've looked at some of the other sessions that are happening at GTC. Certainly one of them that I'm pretty psyched about is the Plumbing the Metaverse with USD. That has some of the originators of USD like Guido Quaroni and Sebastian Gracier or Spiff, a number of other people like Michael Cass and others from NVIDIA talking about how USD is expanding beyond the film industry that it was created in and becoming a standard representation. So please, I hope you enjoyed Plumbing the Metaverse live, or go back and watch that Plumbing the Metaverse panel, because I think that's a pretty good one. So this is what we're going to do here. We're going to talk first about, to get to know what USD is, I'm going to talk about why it was created and how it was created, to kind of understand what the motivating factors were and why it became what it is. And then we're going to go in and talk about how USD is open source, so that what that means and why that's important, how that helps get wide industry adoption. And we're trying to do something different with this talk, in that we're trying to create a place where people can play with USD and can run demos and learn about it, especially like people who want to, say, write some Python that does some things to USD. So we're going to show these Jupyter notebooks and hosted on the Google Colab site, which basically create a little Linux machine on the cloud and then allow you to write little Python scripts and modify USD live inside the browser. And so I definitely encourage you to try that out. Either pause and do it during the talk, or maybe after the talk, so you can focus on what's happening. But either way, I think it would be super cool, and we're hoping that this is a way that people can learn USD. And then we're finally going to show some USD structure inside of Omniverse itself. USD, one of the reasons this is super important to us is that USD is the core representation of the world inside of Omniverse. So back in the day, before Brave was in 2012. So back in the day, there was a bunch of different file formats and different representations within Pixar. So the folks who were putting shots together had a thing called hooks. People layering together animation splines had another thing with a different API to edit it. The rigging system had a very different set of data files and data structures. And simulation, it was all stored in different places and edited in different tools. There wasn't like a single tool that brought all these things together. And so it can be hard to move from department to department as a person, or to move an asset from department to department, because of these differences in the way that data is stored between them. And a lot of people are probably thinking this is not unlike what they experience in their particular industry. Certainly in architecture, automotive, oil and gas, design, there's a number of these industries where you have a bunch of different artists working in different tool sets and editing different kinds of data, and you want to pull all of that data together in and look at it, and it's tough because they're all written in different places and have different standards. And so, the problems that USD is solving, we think are problems that are important for everyone to solve, and hopefully are relevant to you. So I wanted to go through a little bit more of what happened, how we arrived at USD, and how the decisions that were made along the way. So for Brave, we developed the Presto animation system. That was really intended as a tool to bring together multiple different departments. Whereas before, the different departments would have their own tools and their own different expertise. We were trying to bring everybody together to edit the same data in the same tool, and be able to have, load up a shot and be able to edit the layout, simulation, characters, or animation all in the same place. And to do that, when we represent assets, when we represent what is a film breaks down into thousands of little files and that all reference and combine into each other, authored by a bunch of different people to form a single shot. So that's kind of the data that we're editing, is these thousands of files. And that's what that was a very important innovation there. But there was a number of things that were there was another runtime that was developed at the same time, which is super cool. It's called TIDScene. Um, TIDScene. If you saw the Plumbing the Metaverse talk, Spiff made Spiff's team made TIDScene, and it did a bunch of things that were really good that other things didn't do. So with TIDScene, you could load huge amounts of binary data and stream it very fast off disk. So when you want to load those complex worlds, you need to do it fast, and TIDScene did that. And another thing that they did really well on that was that TIDScene was designed to run inside of different applications, so that you could run TIDScene inside of Maya and export a TIDScene file, or run it inside of Houdini, or run it inside of somewhere else. And through that, it was really great at data interchange. That was a big strength. And so we wanted to kind of pull all of the things together into a universal scene description, which combined the best pieces of the stuff that came before. So we wanted to have fast binary streaming. We certainly wanted to have large data storage. We wanted to be able to interoperate with different tools and write out data from different tools to be able to have everything that we need to do to make a shot come together. And you want really powerful and expressive methods to combine all these USD files. You want sort of a different ways of putting them together that give you all of the knobs you need to turn, or all of the structural choices in shot in asset structure that you need. And there. So really, USD is a culmination of 30 years of software development at Pixar that all came together into what we have now. Now, another aspect here I wanted to talk about is Hydra. So Hydra is a rendering architecture that's a part of USD, like it's included in the USD open source distro. And it's a way to be able to take 3D worlds defined in USD and some other things, and be able to pull them out into OpenGL or real-time ray tracing or RenderMan or other things. So it's a rendering architecture. It's certainly used for the interactive. It was originally written for the interactive display in Presto, and we use it inside of Omniverse for real-time ray tracing. Everything rendered inside of Omniverse is going through Hydra, so it's very, very important to us. Here I wanted to show an example of Hydra and USD integration inside of Presto. So this is the raccoon from Incredibles 2. And the raccoon had, I forget, 10 million maybe points on its hair. So you need to be able to take, tens of millions of points and move them around on screen at interactive frame rates. And so, this was a tool designed to integrate with the expensive procedural generation that you're seeing here, and be a place to be able to pump data onto the screen very rapidly. So this is an example of integration with Hydra in particular. And this is also Presto. You can see all of the coral in the background. All of those things are defined in USD. And then Presto has interactive posing system that's going through Hydra. And all of these things come together in Hydra when they get rendered to the screen. This is illustrating that USD and Hydra are created to be, they're a substrate that you build applications on top of. They themselves, USD is not an application, it's just a tool that's designed to help and plug into many different applications. And this is the example that it was originally intended for. And here we're showing some pretty amazing virtual world work that's coming out of our autonomous driving simulation program at NVIDIA. Now you can see all of those blades of grass, all of the road, the cars, that's our headquarters in Denver, Santa Clara, are all inside of Omniverse being defined in USD. So everything here is defined in USD and being rendered through Hydra. And so it's meant to scale up to really big, complex structures. And here we show an integration that we're working on with autonomous driving sims. So this is showing worlds that were built in USD by artists spread all throughout the world, all working independent of each other, combining together into a rich virtual world that we render, which then integrates with the autonomous driving decision-making computers inside of cars. So we're creating a simulated world for cars to train them on how to do autonomous driving. And all of this is flowing through USD and Hydra inside of Omniverse. So a very important fact is that USD is open source. So in 2016, Pixar released USD as an open source software. So, it's almost a million lines of code. All of that, 800,000 maybe, but all of those lines of code were put out for public consumption on GitHub for anybody to download and use. And that's a tremendous step in establishing a standard that other people can use too. So, that's a big reason why the Omniverse team decided to use USD as its core data representation, because it's open source and we have access to all the code, and we can customize it or do whatever we need to do. And it's also key to wide industry adoption. If someone wants to create a thing that interacts with USD, it's free because USD is open source and they can do whatever they want there. There's no license, there's no, and so it allows people to be able to both get access to the technology and have freedom with, say, the intellectual property to be able to work with it without worry. So we want to thank Pixar for doing this. There was patents that were involved in this as well as the technology itself. And it was a very brave move by Pixar to open source this technology, and we'd like to thank them for doing so, because now we get to use it. So this is a demonstration from SIGGRAPH of 2016. This is the day we actually pushed the button to make the repo public on GitHub when we open sourced the software. And everything that you see here is running inside of open source software. So this is a shot from Finding Dory. And so all of that coral, that eelgrass, which came out of a Houdini sim, all the characters, all of that geometry is defined inside of a bunch of USD files that are pulled together here. And Hydra is the thing which is drawing all of this geometry here in OpenGL. And the fact that all of that's included inside of an open source software distro is pretty cool. It's not just how to read the bytes off of disk or how to draw them. It's an entire toolbox of things that you need to be able to create 3D applications. So there it is. This is the GitHub page. Anybody who wants to, the latest check-in there is from Sonia, who fixed a typo. Sonia is a developer on the USD team at Pixar. So you can just see they check in their software here, and you can look at it and you can use it. So that's what it means to be open source, is to have access to this code. And look at, Sonia check in typo fixes. So here is an example from Autodesk. Autodesk has Maya and a number of other products that are used for generating and editing 3D worlds. And because USD is open source, Autodesk can go create a plugin. This was also developed partially, I believe, at Animal Logic, to be able to export USD from Maya. And so now you can get USD out of Maya. Here's another example. This is from Side Effects. Side Effects are a bunch of great folks. Houdini is a product that they make, and inside of Houdini, they've created this data pipeline called Solaris. And Solaris solves a lot of problems for them that they hadn't solved before. And Solaris is a tool for procedurally editing USD. So you can compute USD and flow it around through a network of computational nodes and then send it out to files on the back end. And that's a very, very powerful tool. And they chose to use USD for Solaris, and people are using it and happy with it. Also, here's another example. This is Epic, a bunch of great folks also at Epic, and they have decided to make to build tools to be able to edit USD files inside of Unreal. And that's very important. They've invested a lot of time in really doing this well. And so to see the real-time game engine world think about USD as something that is important to interoperate with is super exciting, because it's very different from the world in which it was originally created. And also Apple. So Apple was looking around to decide what 3D representation should they use for their data. How do they combine files? How do they have people work together with 3D assets? And they took a look and decided universal scene description was a good fit for them as well. Here we have a presentation at their WWDC developer conference, developed by Pixar in 3D file format. You can see the details on the slide. So currently, basically anybody with a relatively new iPhone or Macintosh has built-in support for USD on the machine itself. Generally, people's iPhones, you can just load up a USD file and look at it. Now, one of the things to note is that USD has a ton of features inside of it. We're not going to go through all these features. There's lots of time to learn about them, but know that USD contains a very rich tool set that you can use to solve whatever problem you need to solve. And that was one of the things that Apple liked about it as well. Now, I want to go in a bit of a different direction. And so we're trying to create interactive ways that people at home can try out USD and play with it. Certainly the best way to do that is just to download Omniverse and run it. You may need to have an RTX card to do that. But also here, if you go to usd.nvidia.com, and that's a repository that we have where we have a bunch of examples and documentation about USD and assets that you can download and use. So go to usd.nvidia.com, and there should be a link for Jupyter Notebooks there. You should be able to load the Jupyter Notebook. You can start where there's an introduction to USD one, which will open up a little virtual machine that runs on a Google server that allows you to write Python and edit USD from within the browser. So here, I just want to show, definitely go to the browser, usd.nvidia.com. That'll bring you to this site here. So it has some descriptions of what USD is. It has some nice videos, documentation. It has some downloads for artifacts or for assets as well. And so in here, it's not there right at the moment, but will be soon. Will be a link for these Jupyter Notebooks that I'm about to show you. About to show you here. So this is a Jupyter Notebook. And again, it's a little virtual machine, a little Linux machine. And when you hit those little play buttons, it is running a little bit of Python inside of that little virtual machine. And what this did was install USD inside the virtual machine. And so here are some examples. This is another body of Python code that's going and creating some geometry in a scene and setting some attributes on it and creating a USD layer and saving that USD layer. We're going to go into detail on a further slide about what that just did. But one thing I want you to note here is that this is live Python. So that's a green 00001, and you want to change it to a red 100. You can just do that, hit the play button, rerun the Python, and regenerate the USD code. So we very much hope that these Jupyter Notebooks are a good way for people to play with USD and learn and get a little familiar with it. And it is a real machine with a file system. So we generated a file that you can then download. So that little sample layer.usd that we just generated, if you were to download it and email it to yourself and open it up on an iPhone, you would see a 3D sphere because USD is supported there. So I wanted to go into a little more detail about what we just looked at. And I'm going to go through the code. I know there's a lot of text on the screen, but don't worry, it'll go quickly. But I think it's important to talk about the fact that USD is both a runtime with an API that you call, as well as a file format. It's much more than just a specification of a file on disk. So on the right, we go to the PXR namespace, and we import a couple libraries into Python, these two the USD and USD-geom libraries. Then we go in and we create a stage. So sample layer.usda. A layer is like the file on disk, or it's like the place in memory that's receiving, that holds onto the data. And a stage is a thing that brings together a bunch of different layers and gives you an interface. And you can see stage has a bit of filmmaking history there, but you can see that's the final composed scene that you can look at of all of the layers put together is a stage. Then we create a transform, an XForm, and we set a translation, 7 and X, 8 and Y, 9 and Z. So XForm with a translation, and then we create a sphere underneath that XForm. And then you can see we grab the sphere, we grab the prim. So we call when you create a thing in USD, it's generally a prim, like a mesh is a prim. So we created a prim, and we got the prim from it in the scene. And then we grabbed a couple attributes here. We grabbed a radius and an extent and a color, and we set some of those attributes, and then we save it. And then if you look over on the left-hand side, you can see the file that was generated. You can see that X form that we created. Then you see the sphere that we created. You see that the translate is on the X form, not the sphere, because that's what we did in Python. And then you can see those values for radius and display color and extent that we modified. So file on the left, API on the right, which generated the file. I wanted to go into another example. This is referencing and overrides. So this is just a first example of how USD files combine together. So we created a file in the last example where we wrote out a sphere and a transform, and it's on disk. Now we're going to go into this file and we're going to reference the last one. And so what that does is it basically pulls that sphere into our scene, but the actual storage of the information is still kept on separate layers. And so here on the right, we create a stage in memory. We create an over that is a place that we're going to put opinions, and then we're going to put values and stuff in. And then we add a reference to that sample layer that we created last time. And then once we added that reference, the sphere is there in the world, and we can just go get it. So we got the sphere, and we set the display color on the sphere, and then we wrote it out. So if you look on the left, a crucial thing to note here, a couple things to note here. One of them is that when we added that reference to the USDA file, it didn't just copy the whole thing in. It's still a separate file. We're referencing it, but there's still two distinct places where stuff is stored, two layers. And then on the bottom, we modified the color of the sphere, so the display color of the sphere. So sample layer.usda had a value for display color, and we do also. And so when we saved it, that's an over, and so that display color, our display color wins because it's in a stronger layer. So we took the sphere and we made only the sphere red, but we didn't have to duplicate the rest of the information in the scene to do that. So that's composition, and super important to what USD is. Now, I wanted to also talk about how USD is the core of Omniverse. Anything defined inside of USD, a physics model or a piece of grass or anything, all of those things are defined in USD. And we take advantage of USD, and we have extended USD in a number of important ways in order to facilitate collaboration. But USD is at the core of Omniverse. It's all about USD. So I wanted to show you the interface. This is Omniverse. We're not going to show a lot of Omniverse here. This is just kind of a little, we're just dipping our toe into it. So I do encourage you to see some of the other great Omniverse sessions at GTC to get more information about the tool. But I want to show how USD fits in Omniverse. So we have those three example files below. The variants we haven't talked about yet, but we will. So I'm going to start by pulling in sample layer, that little USD file that we created. Now we actually see our blue sphere. It's real-time ray tracing, but you can't tell because it's flat blue, but it is. And now those attributes that we wrote to in USD now appear in a user interface. And so those things on the bottom right where we were editing attributes are just direct reflections of the attributes that exist in the USD file itself. And we're creating an interface that allows you to edit that 3D world by modifying the USD. So here we created a light in USD, and we're going to duplicate the sphere a couple times, and we're going to move things around. And again, this is all super simple. There are much more complex and rich and interesting workflows in Omniverse, but I'm just trying to show that all we're doing is doing the same kinds of things we were just doing in Python, except we're doing them from a nice interface that's hooked up to a real-time ray tracer. And I'm going to show one more, a slightly more complex example of composition. So here we have variants. So variants are a way to be able to say, here we're doing it very simply. I want a sphere that's blue, red, or green. But it allows you to have like a switch that sets a bunch of values in scene description. So you can have a variant of a character with a sweater or without a sweater, or wearing shoes, or with purple socks or brown socks. There are ways to express variation. I want a car, but I want a Ford, or I want a Chevy. That's a variant. And so it's a way that you can use USD to combine together and still allow you control over how you decide how those pieces fit together and vary within your scene. So it's just one example of composition within USD. And now one last example here. This is loading a full and complex USD file into Omniverse. So everything in here is defined in USD, but now it has textures, and now it has materials, and we have some lighting, and we've got some fog. And so it's still just USD files. So when I take this hobby horse here and I move it, you can see in the bottom right that all I'm doing is changing a couple values in USD. And we've created an interface to set those values. And then Omniverse then takes that three-dimensional world of USD and puts it into this ray tracer and allows you to show a real-time ray traced image of edited USD. But still, USD is at the core here. So I hope I haven't said USD too many times, although I think maybe one too many, but I hope that you've learned a little bit about what it is and why it was created and what problems it's trying to solve. And I encourage you to think about how those problems might apply to the industry that you happen to be in, where you have difficulty in bringing data from one tool to another, from one department to another, from one company to another, and where standard definitions like USD and open standards can help you solve those problems. Thank you for your time.